A very good morning, good afternoon, good evening to all my friends, participants and candidates who are taking this course under NPTEL MOOC series, and the title of the course is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, the three broad areas which we plan to cover in this course are as follows: averaging technique and forecasting concepts, which is part 1, part 2 is basically the ideas of regression model, and part 3 is the ideas of time series model. And as you know, we are covering the concepts of averaging techniques and forecasting, and today as of now is basically 4th week classes are going on, which is the 17th lecture, which is in the 4th week as I mentioned. Now, if you consider the ideas for the last week, it was basically the idea where we are considering one simple example. One was related to the tutor problem, where the forecasting concepts were being considered for tutor demand being given and we are trying to forecast. The second problem which we started, which will continue today, is basically about the furniture company. And in this furniture company, the one extra information which is needed in the problem as asked is basically to compare the matrix based on mean squared error. So, we will do that accordingly. So, the problem was basically to utilize the concept of exponential smoothing concept, and the idea in the first part of the problem was basically to do the forecasting based on alpha is equal to 30% or 0.3. The next part of the problem was basically to predict it for 0.5 and then to do it for a trend analysis, or considering very simply the ideas of adaptive concept. Not in that detail what we have done, because we have done the one parameter adaptive model quite detailed with the Excel sheet and the graphs. And the fourth part of the problem would basically be to compare the mean squared error. We will continue doing that. And the other coverage which you see in this class is matrix can give different answers with respect to the models, that I will try to definitely consider in this class. So, the part 2 of the problem is basically to do with the idea that you are going to consider the alpha value as 50%. So, which is given here, if you note down where I tick marked it. The 50% means you are giving equal weightages for the forecasted value and the actual value being y or d, forecasted value being f, and you are giving equal weightages to them when they are in the tth time period, and utilizing the tth time period forecasted value on the actual value, you are trying to forecast for the t plus 1 time period. So, I will draw again, even though it may be a repetition, please bear with me. So, the timeline is basically for the y, the red one or the black one, and here where you have basically yt. The dark red one is basically for f, and you have basically ft here, and this is basically ft plus 1. So, what you are trying to do, you are trying to give equal weightages of alpha for ft and alpha for yt. So, that alpha can be changed accordingly. If you remember, in part 1 of the problem it was 30%. So, the formula to be used is as follows, which I have already mentioned. I will use a different color. So, to highlight, you are trying to give weightages of alpha to dt or yt and 1 minus alpha to ft. Based on that, you want to find out ft plus 1. Here we consider dt as equal to yt for our convenience, and that I have highlighted time and again. To determine the forecast of January, we need to know for December, and to know about December, we need to know about November, and so on and so forth. Now, in part 1 of the problem, I mentioned the time and again, which was a little bit different from the concept of exponential smoothing or the weighted average which we have considered. It is basically the exponential concept we are using. What we have is basically the data from January to February, which is y1 to y12 or d1 to d12. We need to forecast for January next year, which is F13. Now, to find out F13, we need F12. Similarly, to find F12, we need F11, And if we continue going backwards, we will find out that we need also f1. Now, f1 may not be given. So, what we will try to do is that consider f1 value is equal to y1 or d1. So, this may be an assumption which I mentioned when we are considering alpha as 30%. I also mentioned that when we are considering alpha as 30%, we can take the past values average value as the best predictor for y1. But here, as the past values is not given, we will consider y1 as equal to f1 or d1. So, this is how we are considering. So, again if I consider, I am giving 50% weightages to both f and t. Now, here you note down, which I just mentioned few minutes back, that y t and f t are same, which is 37, which is based on the assumption. And if I consider that concept of 50% weightages to y1 and 50% weightages to f1, the value of f2 comes out to be as follows, is 37.0. Similarly, based on the value of f2 and y2, the value of f3 comes out to be 38.5. If I continue doing the calculation, for the final value what we will have, if f13 will be given by 50% weightages on the actual value, which is y12, and the predicted value, which is f12. F12 is, if you remember, comes out to be 53.21. I am using the blue color to put a tick mark, and the final value comes out to be 53.61, which is f13. Now, for part 3 of the problem, it says that we need to find out using the trend. Now, the concept here, generally the background of the problem and the way to solve the problem is exactly the same what we have done. Maybe some symbols are different, of the ideas how you basically consider solving the problem may be different, but be rest assured the concept what you have learned for the exponential smoothing average using either the fixed beta, which you have already considered, and for the adaptive method we have already considered in much detail, but here we are doing a slight twist in the problem, in the sense that we are using the concept of the ideas of trend. Trend mean average value, and the average value graph and how it basically looks, I will again draw. So, say for example, I will use the blue color as for the axis, and if I consider the data, I will use the red color for the data. So, see for example, it is fluctuating like this. It can be. So, what I mean by the average value, I will use green color for the average value. This is the trend which I want to have. So, obviously, there is variability, but my main focus would be basically to assume there is a trend. Variability is, or standard deviation is, a difficult proposition to handle, especially as I mentioned for time series data with related to financial data. Time series data is obviously in all the cases, because in the x axis of the graph which you are plotting is the time frame. It can be month, year, quarter, week, days, as the case may be. So, the formula to be used here, let me read the problem when using the trend, is like this. Now, I will highlight what are the parts, and I will keep the diagram and highlight them using one color at a time. So, dt you know is basically the actual value of yt, and the concept of at minus 1 and t minus 1 with the suffix t minus 1, at minus 1 are the corresponding trend and the smoothing trend which you have. Now, the question can be asked, is it that depends on some concept of adaptive exponential concept? Answer is yes. You can also solve the problem using the simple detailed problem solving what we have done for single parameter adaptive concept. Now, the only fact we are trying to utilize is there is a trend, that T is the trend, capital T is the trend. So, in many of the problems, if you remember, the symbols may be different or the parameters may be different, but the idea of how you are expressing the trend, how you are expressing the error minimization, how you are expressing the cyclicity, how you are expressing the seasonality, how you are expressing the lag, would all basically boil down to the same concept. Trend is basically the average. Cyclicity would basically depend on a cycle, how is it fluctuating. Seasonality would basically, the idea comes from the seasons, 4 seasons in a year, and the variability would basically be concept related to the variance only. But obviously, in many of the problems you can see the variability can be construed or tried to analyze in a different way, because based on the variability of the error concept which you have, we saw that there can be different metric being mean squared error, absolute error or mean of the absolute error. It can be weighted absolute error, it can be weighted mean square error, it can be percentage error, it can be weighted percentage error, it can be U statistics, as the case is, and we will come to that hopefully in this class, depending on how the coverage and how detailed I want the coverage and the discussion to be, because as I am not interacting with the students, I will try to keep it as detailed as possible, so that it is clear both in the video as well as in the slides to the maximum possible extent. And if you have any queries, you are most welcome to ask the TS, and we will try our level best to answer to all the queries as fast as possible. So, T suffix T, the suffix obviously means the time, T is the trend, and I am basically taking the trend as the weighted one. If you remember, we had taken the concept of A and M also in the adaptive exponential smoothing. So, beta is the weight, in exactly the similar way we had the beta, and T suffix T minus 1 is the trend value for the last value. So, obviously, when you are starting the value, we would not consider any trend to be there, and AT and AT minus 1 are basically the corresponding ideas for the smoothing concept we will try to take for the trend. Now, remember, as this is a trend in this graph, the red one is the actual data, green one is the trend. So, how do we basically consider the fluctuation? So, if I consider the fluctuation to be given by the color, say for example, violet, and that is why I did not erase this graph. Consider the fluctuations are there where hence it is normal. So, these fluctuations have to be minimized as far as possible. That is why this concept of AT comes in a way that is akin to the fact that I am trying to minimize the fluctuation and bring it down as possible and make the fluctuation in and around the average value and make it as low as possible. So, if using the above to we find out the value of the trend and the fluctuation. Now, here there is a certain change in the concept. Generally, we know the idea of f t plus 1 is given by alpha f t plus 1 minus alpha y t, same, because you give the weight to alpha to y t or 1 minus alpha to y t, does not change the concept, so long you are able to make the problem clear with respect to the parameters. Now, here what the difference is with this concept is likewise. Here the forecast is given by two facts. One is the trend, which is the average value, and one is the fluctuation. So, that means trend is the average which we will find out and add or subtract the fluctuation such that we are able to give the forecast to the maximum possible extent. Now, technically what is trend? Trend, if you find out the actual values of y. Now, if I am able to fit the best fit line for the y values, I will get the line which is given by the green one, which is basically the trend. So, if you remember in some of the diagrams which you have given, and we will see later on in the regression models, that the trend is basically the best fit line we are trying to take. So, actually trend plus the fluctuations would give me the actual values, which is f t plus 1, and obviously we will take the trend for t suffix t and fluctuations for a suffix t. For period 2, we will consider this. So, considering y a naught is 37, and if you remember the trend is as you remember, if you have heard my point earlier, I would consider the trend for time period t 0 is 0, that means the trend has not started. So, the a naught value will be 37, and what is a naught? Please excuse me, I will go back to the slide accordingly. So, here for part 2 of, I will go back to a previous slide. So, if I consider the value of 37 was there. So, 37 was basically the month of January's value. So, this is basically as taken as the actual value from where we will be starting. So, trend is 0, actual value of the so called fluctuations or the starting value of the trend is 37. So, using this data and using the fact that we will be utilizing beta as 30% and we will use alpha as 50%. So, alpha is basically here when we try to find out A and trend value to be found out using the value of beta, which is here. So, there are two steps, find out A1 based on A0, and once A1 is found out, if you basically utilize it to find out the next trend, and based on the trend you will find out the forecast. So, A1 is given by 50% of y value plus 1 minus 50 of the values of the initial A0 where we are starting plus the trend. Trend T0 is 0, E0 is 37. Based on that, I have A1 as 37 as given. Now, based on that, I need to find out the next step trend, because given A1 and T1, I will be able to find out Ft plus 1. So, T1 would be giving weightages of 30% to the difference of A1 and A0. So, A0 is from where you are starting, the so called starting value of the average value. I find out the value of A1 next and find out the difference of A1 and A0. That means basically the fluctuation which you are considering. Now, remember, in actual data, as the data varies, A1 can be less than A0 also, A1 can be more than A1 also. So, the difference between A1 and A0 can be positive or negative. So, do not be bothered if in some problems when you solve in practicality, the difference between A1 and A0 is either positive or 0 or negative. It can be 0 also if A1 is also equal to A0. So, based on the fact that we put 30% weightages on the difference of A1 and A0. So, A1 was 37 found out, A0 was 37, and based on that, if you have T0 as 0, the value of trend as it starting is T1 is basically 0. When I find out F2, F2 is A1 plus T1, it comes out to be 37. For period 3, we first consider the formula. So, again consider the alpha value and beta value as given, they would not be changing, because with respect to the adaptive one, this is not as complicated as the adaptive one. Here we are only considering the trend. So, A2 would be 50% weightages multiplied by Y2, which is D2, plus another 50% weightages given between A1 and T1, that comes out to be 38.7. Based on 38.7, you find out the value for T2, which is basically beta weight multiplied by the difference between A1 and A2 and T1. So, that comes out to be T2. That means, trend has now changed from 0 to plus 0.45, which is positive. Based on that, when I add up A2 plus T2, I find out the value of F3 as 38.95, and based on that I can find out. So, the values are not given, but I will urge all the candidates and the participants and my friends of this course to please utilize, because the slides will be shared with you. So, you can download the data, utilize the data and use different values of alpha and beta to find out the concept of trend and how the graph looks like. Because the reason being, I have done in details about how the graphs look like for the one parameter adaptive concept. Now, for the last part of the problem, to compute the mean square, we need to find out first the error. Error is basically the difference between y and f or d and f. Et is the error of time period t, as we already denoted, and the mean square error would basically be the sum of the square of the errors finding on the average. So, it will be E1 square till En square, add them up, divide by n being the number of readings. Now, here is the graph, and please pay attention here, because when you do the calculations depending on either alpha as 30%, alpha is 50% for the second part, third part being for the case when you are considering the trend, and based on the fact you consider that T naught is 0 and A naught is the starting value for the month of January. If you put that value considering alpha and beta as given, alpha is 50% and beta is 30%, based on that if you do the calculation, please check the table which you get. So, the period from 1 to 12 were given, which is January to December, values are given from 37 to 54. So, this is the first column based on the period, this is the second column based on the concept of month, this is the third column based on demand, and the problem was basically part 1 of was exponential smoothing for 30%. So, the 30% is given here. So, this is basically the fourth column which you have. The second part of the problem was given for alpha as 50% for exponential smoothing. These basically correspond to the fifth column. The corresponding values which you have in the sixth, seventh and eighth are the values for AT, TT, FT. What is AT is basically the starting values of the forecast, so called forecast, and T is basically the trend, positive and negative can be if it is decreasing, and the last column is basically the forecasted value. Now, the initial assumptions are given as alpha is 50%, beta is 30% as already done in the problem. So, based on that, if I have the values which are given in the fourth column, there you give 30% weightages and 70% weightages to either FT and YT, depending on how you have been able to specify the weightages which you will give for F and T. In the fifth column, you are giving equal weightage of 50% to both F and T. So, hence the values are as follows. So, I will mark the fourth column as the corresponding forecasted value for exponential smoothing alpha is equal to 30. The next column which I will mark in dark red are the corresponding values for exponential smoothing concept of y based on the idea that alpha is 50. And the last three columns which you have, where the column 6th and 7th are for A and T, are the values which you will take to find out the last column, which is the forecast, which I marked in violet color. Now, the idea was basically you can compare and find out the error. Now, that part I'll leave that to the students to solve the problem accordingly. Now, another important part, interesting part for this coverage was basically to compare where the metric may not give us the same result, considering one model to be the so called best, and I will utilize the data which I have already used for the one parameter adaptive model. So, even though it is a repetition, I will basically mention the ideas of the problem background accordingly. So, the first column is for months starting from January to December 12. The second column is basically denoted as the time period, just an added extra column. Third column is basically the y value starting from 200 to 235, and obviously December is not there. It was also not there in when we utilized the same data set to solve the adaptive single parameter model. And what we have utilized is, rather than go into solving the adaptive single parameter model, we are stuck to the simple case of utilizing the non-adaptive single parameter model. So, the forecasted value for 10%, 50% and 90%, as we have done earlier, remember, are given in 4th column, 5th column and 6th column respectively. And as usual and as per assumption, we have taken the month February forecasted value, whether for 10% or 50% or 90%, as equal to the actual value, which is y1, which is corresponds to the month of January. So, hence the blue lines are there. So, this 200 value, which is for January, is taken as the predicted value for month of February, whether for the case of alpha is equal to 0.1, alpha is equal to 0.5, alpha is equal to 0.9. Based on that, if I give the weightages, it means that I am giving weightages here. I will use one color, the coloring at a time. So, say for example, alpha is equal to 0.1 and 1 minus alpha is basically given by 0.9. Here alpha is given 0.5, 1 minus alpha is given as 0.5, and for the last case alpha is given as 0.9 and 1 minus alpha is given 0.1. So, based on that, when I do the calculation, so consider I am utilizing the data set as here. So, if I consider this, so what I will do is that I will consider the last two values of f1 and y1 to predict for f2. So, let me use the violet color. So, when I am trying to find out 193, which is the next value, so technically I will give weightages for 0.1 into 135, which is y1 plus 0.9 into the weightages which I am giving for 200. So, this would become 13.5 and that would become 180. So, addition of these values becomes 193.5, which is already marked here. Similarly, if I go to so this is clear, so I will erase this. So, if I go to the 167, it will be 50% of 135 plus 50% of 200. So, that becomes 2 6 are 12, 2 7 are 14.5 and 200 means 100.0. This is 167.5, which is the value which is already given. So, based on that I can calculate and I do it for all the columns. Now, having done that, so what I now want to concentrate is this. I will erase the calculations which are done here. I will not erase the column which are being marked, because they will be utilized to better explanation. I will use different matrix for comparison, and the matrix for comparison which I will use is based on the fact that I will use the following columns. So, I will basically concentrate on column number 3 and compare that with once with column number 4, I will put 1 tick mark. Second, you compare column number 3, which is y, with column number 5, where I put a 2 tick mark, and then again you compare y, which is given in third column, with the 6th column, which I put for the third tick mark. So, they are 4th, 5th, 6th are corresponding to the forecasted value for alpha is equal to 10%, then 50% and then 90%. Now, once you do that, you plot the values of y with respect to f for 10%, f for 50%, f for 90%. What is 10, 50 and 90 means? They are basically for the corresponding value alpha. So, if you see y is given by blue, the f for 10, f for 50, f for 90 are given by dark orange or dark red, then grey and yellow, and if you see, the orange one is almost a straight line, because you are giving the maximum weightages based on 50% and 10% and 90%. So, it is almost smoothing out, almost a straight line, and the maximum fluctuation which mimics how the data set would be, but with one lag, is basically for alpha is equal to 90%. So, if you follow the yellow one, it is lagging behind with respect to the blue one, which is the actual data. Now comes the interesting proposition. When I compare, and this is what is an important learning point for all of us for this course. If I consider the values of alpha, which is given as 0.1 for the second column, third column for alpha 0.5 and fourth column for alpha 0.9, and the first column are the different metric. What are the metric? Mean error, mean absolute error, mean squared error, mean absolute percentage error, and U statistic. These formulas have been dealt in detail, which I will again do that when I am doing the other ideas of Holt method, Holt-Winter method, Holt-Winter being adaptive or multiplicative, considering the seasonality concept. If you plot the values for mean value, very interestingly for alpha 0.9, it is the least, which I circle in red. But when I use the mean absolute error, mean squared error, MAP and U statistic, the first model, which is based for the concept of alpha is equal to 10% is the best. So, the question is that, are we doing something wrong? Answer is no. Depending on the assumptions, depending on the parameter values, you can get different metric can give you different answer which is best. And this is a learning point, that do not consider one model to basically be the best and be able to solve all your problems, all your forecasting. It will depend on the context and the assumptions you are taking. I will highlight this concept more later on in a much more in depth for other problems, as I mentioned for the Holt method and the Holt-Winter method. And considering such concepts of where the metric may not give you the best result in all the cases for one model, in the regression cases also. With this, I will end this class and have a nice day, and thank you very much for your attention.